Correct. All right. Good. He's also a computer science PhD candidate in AMP Lab at UC Berkeley, where he co-created Tachyon, an open-source memory-centric distributed storage system. He's also a founding committer of Apache Spark. Before Berkeley, he worked at Conviva and Google. Hayuan has a master's from Cornell University and BS from Peking University, both in computer science. So welcome.
Thank you. Hello. Hey guys, happy to be here. So I'm going to present how the company is using Tachyon, a memory-centric distributed storage. And this presentation is going to be given by me and my colleague, Iri Samsa. And let's see. Oops, let's do it again. So he's also from Tachyon Nexus, and he got his PhD from CMU, and he was working at Google before. So just a little bit about the company before the tech presentation. We are Tachyon Nexus. We're a team formed by Tachyon creators and top contributors. And we got our Series A from Andreessen Horowitz, and we are committed to the Tachyon open source project. And of course, we're hiring. So if you know anyone, please refer to us. I will appreciate that. So here's the outline of the talk. At the beginning, that's the introduction to Tachyon. And then we're going to talk about some Tachyon use cases and some new features, exciting new features from Tachyon and how to get involved. So I'm going to give the first part, and the rest part will be given by Iri. So here's a history of Tachyon. So we started Tachyon in AMP Lab UC Berkeley in the summer of 2012, and it's the same lab which produced Apache Spark and Apache Mesos. And we open sourced Tachyon in April of 2013 under Apache 2.0 license. And the latest release is actually several days ago, 0.8.2 in November. And the project has been deployed at more than 100 companies. And the project has been growing pretty fast. This is just a figure to show one metrics, which is the contributor growth. At the beginning, in our 0.1 release, we had one contributor. And then after that, we had a 300% increasement to be 3 contributors. And then we had 15 contributors for our 0.3 release, 46 contributors. Oh, this is the 30 contributors for 0.4, and 45 contributors for 0.5. And then 0.6, it's around 70, and 0.7, it's 110, around that size. And for 0.8, we have more than 170 contributors. And the contributor has been growing pretty fast. And over the past year, the number of contributors has grown more than 3 times. And there are more than 50 organizations are contributing to this project nowadays. And it is one of the fastest growing big data open source project. And I want to take this opportunity also to thank to our contributors and users. And you can see on top of this slide, all these bubbles just auto-generated for the people who ever contributed to the project. And this is from our website, project website. And the bottom, that's a sub list of the companies which are either using Tachyon or just contributing to the Tachyon system. And there are various reports about the project as well. It's in Fedora channel. It's the default storage solution for off-heap storage solution for Spark. And people are using this Tachyon to exchange data between different frameworks. And the EMC and Pivotal, they announced that Tachyon will play a very critical role in the future data lake architecture. And nowadays, IBM is also putting resources into this as well. So that's a very high level and basic summary of the Tachyon project. And now I'm going to hand over to my colleague to talk about the Tachyon use cases as well as the new features we developed over the past year and how to get involved with the project.
Thanks, HY. So my name is Hayuan. I'm a software engineer at Tachyon Nexus. And as HY mentioned, I'm going to talk about some interesting Tachyon use cases as well as features of Tachyon that we have recently developed. So the star use case for Tachyon that we have is Baidu is using Tachyon to significantly speed up their Spark SQL pipeline. And for that, they use Baidu's file system and as a storage for Tachyon. And I'm going to go a little into how architecture of Tachyon works in the next section. They're using both memory as well as hard disks. So they're using the tiered storage for Tachyon storage. And below that is the Baidu file system. And they're running over 100 Tachyon nodes, managing over 1 petabyte of data. And by deploying Tachyon, they were able to speed up their pipeline by more than 30x. That's 30x, not 30%. We have a couple more use cases. For these use cases, they're actually anonymized because the companies that evaluate Tachyon wouldn't want their names to be disclosed at this point. But this company, it's a SAS company, and they're using Impala as their computation framework. And their data is stored in S3. And they're using Tachyon configured with both memory and SSDs as the in-memory or memory-centric storage layer. And by using Tachyon, they were able to get a 15x performance improvement. Another example of a Tachyon use case is an oil company that uses Spark for their big data analytics, storing their data in GlusterFS. And in this case, they're configuring Tachyon only with memory. So in this case, you can think of them using Tachyon primarily as a distributed cache. However, as we will find out later, Tachyon can actually do much more than just be a distributed cache speeding up your workloads. And a final overview of a use case. It's another SAS company, again using Spark as their computation framework and S3 as their underlying storage. But this time, this is an interesting use case of Tachyon, is they're not using Tachyon with memory. They're actually using SSDs as the primary storage for Tachyon, because it turns out that for this particular case, that's the optimal price point for their deployment. And it kind of highlights the fact that the elasticity of Tachyon's deployment. Sometimes it makes sense to configure Tachyon with memory, while other times SSDs might actually be the best price per performance data point. So after giving you an overview of some of the use cases that exist already out there of the Tachyon open source project, I'm going to talk about some of the new features that me and my colleagues at Tachyon Nexus and also the rest of the open source community contributing to Tachyon has worked on over the past couple of months that, in my mind, really change or broadly extend the capabilities of Tachyon. So as HY already mentioned, Tachyon 0.8.2 has been just released. We released 0.8 in late October, and since then we had 2 maintenance releases with both bug fixes and also performance improvements. And you can go to our project website to download the latest release in case you would like to play with Tachyon and start using it. And so now I'm going to get more into talking about what Tachyon really is for those of you who might not be familiar with Tachyon. So Tachyon sits kind of in between the computation framework and traditional distributed storage systems in the big data stack. And it's really a layer between computation frameworks like Spark, like Hadoop MapReduce, Apache Flink, that can be used, among other things, for keeping data close to where the computation happens in a reliable and memory-centric fashion. And that's kind of what's resulting in the astonishing speedups that we've seen in some of the examples for the use cases. And Tachyon's architecture makes it really easy to add support for additional computation frameworks. So if you have a computation framework that's not already on the slide, or this slide is actually not a full enumeration of all the frameworks and understorage systems, it's not that hard to add support for it. Tachyon actually offers an HDFS client out of the gate. So if your computation framework is used to talking to an HDFS file system, you can start using Tachyon right away. And Tachyon also offers a native file system API, which we recommend people to use if they really want to unlock the full potential of Tachyon, because it gives you features that the HDFS client doesn't. And on the other side of the Tachyon, on the bottom side, we have the storage systems. And so Tachyon already has integration with the storage systems like Amazon S3 or HDFS or GlusterFS. And these are all independent modules in Tachyon, kind of adapters or connectors. And it's again, not incredibly difficult to add support for a new system. Just recently, last week, I talked to one of our open source contributors who's interested in possibly adding support for Microsoft Azure. And I think that it's not a one-year project requiring a team of people. I think one or two contributors should be able to do something. The initial support maybe in a couple of weeks or maybe a month. So it just highlights the modular nature of Tachyon and hopefully explains or demonstrates to you where Tachyon sits and what it does. One of the common misconceptions about Tachyon is that Tachyon is a distributed cache for Spark. And maybe that might have been true in the early days of Tachyon, but since then, Tachyon has evolved dramatically. And it's not just distributed cache, and it's not meant to be used just with Spark. And one of the features that really highlight the difference is the fact that Tachyon can manage more than just memory. It can manage data across different tiers, be it memory or solid-state disks or hard disks. And it is really up to the users to configure Tachyon with the type of storage system that makes the most sense for them. And in the uses out there, we've seen actually different configurations of Tachyon. Some of them are the more traditional configurations of Tachyon using memory only, while other configurations use both memory to keep the hot data as quickly accessible as possible, while using hard disks for keeping maybe not so hot data, but the data that still needs to be stored locally with respect to the computation. While yet another examples we've seen Tachyon being used with SSDs, because that was the optimal data point with respect to the price and performance trade-off. And Tachyon provides a configuration option where you can specify what tiers and how tiers should be layered. Related to the tiering approach of Tachyon, it might not be surprising that Tachyon also provides policies for specifying the data management across the different tiers. So how should be blocks, if you run out of space in memory, which blocks should be pushed down to the lower tier, or if you're accessing data that's stored in hard disk, but you also have memory for Tachyon, which of these blocks, which of this data should be promoted to higher tiers, because there's an expectation that this data will be accessed again reasonably soon, so temporal locality. With the latest version of Tachyon, we have really changed the way Tachyon interacts with the underlying storage systems. So until the 0.8 version, Tachyon namespace was disconnected from the namespace of the underlying storage system. You could organize your data in Tachyon, and it kind of looked like a file system. But if the data was persisted to the underlying storage system, like HDFS or S3, you would then look at the Tachyon work folder where the data was being stored, and you would just see one directory full of files with random IDs, and you wouldn't really know how those files correspond to the files that you've created in Tachyon that appear in your Tachyon namespace. With the latest version of Tachyon, we implemented transparent naming, which maintains this identity, this mapping between the namespace in Tachyon and the namespace in the underlying storage system, whether it's HDFS, S3, or ClusterFS, or any other underlying storage system that you would like to use. And so when you create objects in Tachyon and you create directory hierarchies, the names and the hierarchies are reflected onto the underlying storage system. So when someone wants to access directly the S3 bucket or the HDFS cluster, they don't end up seeing just a bundle of random IDs, but they actually end up seeing a meaningful directory hierarchy and meaningful directory names. Another feature that really, in my mind, redefined what's Tachyon capable of is what we call unified namespace. Again, prior to version 0.8, Tachyon could only use a single underlying storage system. Right? So you could run Tachyon either with an HDFS cluster or an S3 bucket, but you had to pick one. With the latest version, you can mount different underlying storage systems under different paths in Tachyon. This is analogous to how in a local file system you can mount different partitions onto different paths in the namespace in a traditional POSIX file system. And so what it allows Tachyon to do is to provide a unified namespace of possibly distributed, and by distributed I mean multiple data sources, multiple HDFS clusters or HDFS clusters and S3 buckets, and all of that is surfaced through a unified namespace, paths or URIs that all look the same irrespective of whether the actual data lives in the S3 bucket or an HDFS cluster. And Tachyon also provides an API that lets you mount new data sources on the fly to existing Tachyon deployments or unmount existing ones. So you can kind of plug and play with different data sources. Some of the additional features that I'm just going to quickly go through is the latest version of Tachyon also supports remote writes. Until the latest version, it had to be the case that there needed to be a Tachyon daemon running on the host that was generating the data to be used in Tachyon. That's no longer the case. It's always better if you have the Tachyon daemon running at the node because you get better performance. But in some cases, that's actually not possible. Like front-end web servers, maybe it doesn't make sense to be running Tachyon daemons on the front-end web servers where you're collecting your click data. And for those cases, you can use the Tachyon's remote write API to just send that data to Tachyon as opposed to send that data to the underlying storage system from which the Tachyon would then read it, which wasn't as performant. We also simplified deployment of Tachyon to existing clusters, namely clusters that are already maintained or managed by resource managers like Mesos and like Yarn. We have the Tachyon framework for Mesos that lets you start Tachyon on an existing Mesos cluster. And similarly, we have a component for Yarn that lets you start Tachyon on an existing Yarn managed cluster. Until the latest version, we didn't really have a concept of users or security, and that's something that's being introduced and still actively worked on. And we have some initial work on that in the latest version. We also have a single command deployment, which lets you just go from nothing to a cluster running on AWS that has a computation framework, an underlying storage system, and Tachyon deployed. So you just say, I would like a Tachyon cluster with 10 nodes because I would like to profile it. I would like to try my workload on it. And 15 minutes later, assuming you have an AWS account, you have a cluster that you can play with. And we also have an API for collecting monitoring metrics of the different components of Tachyon. So after talking about the new Tachyon features that, as I said, in my mind, they really changed the way I think about Tachyon, because it's definitely the case that it's not no longer just a distributed cache for Spark. It's much more than that. I'm going to talk about how can you get involved, how can you use Tachyon or contribute to Tachyon. As HY mentioned, the growth of the open source community has been pretty astonishing, and we welcome the new contributors. We have a Jira issues where people can go and look at new contributor tasks that help them onboard. And there's a list of resources here that people can go and look at. There's the project web page where people can download Tachyon. There's the GitHub repository where you see all the pull requests, all the development happening there, all the discussions. We have a meetup group. We have fairly regular, I would say, once every 2 months, we have some meetup. Either like the last meetup was, for example, at Baidu, where we talked about both the Baidu's use case as well as a use case from Redhat, as well as some of the new features. The company website, in case you would like to get involved not just in Tachyon development, but also in Tachyon Nexus. To contact, you can contact HY, or you can also contact me. That would be replacing HY with my name, JIRI. And with that, I'm done, and I'll take questions. Okay. Thank you again.